Hello, and welcome to a very special episode of Crash and Burn Science 101.
Hey, welcome to another episode of Crash and Burn 101. Today we're going to be learning about the plate tectonics. The beginning of the theory began long ago in 1912 when Alfred Wegener, a meteorologist, suggested that continents were connected and have moved apart over time. Now this was a fantastic idea, but there was no way to prove it. No advancements were made in this theory until after he died. How tragic.
After his death, many pieces of evidence showed up to prove him correct. One huge discovery was that the magnetic field was shifting on the ocean floor. During oceanic divergence, a subject we will talk about later. The magma that spills from the ridge has minerals that align relative to Earth's magnetic field. With the correct instruments, changes in the magnetic field can be detected. These changes are symmetrical on both sides of the ridge. This new crust can also be dated to show that the new crust is closer to the ridge and the old stuff is farther away. On land, the continental crust is even older, showing that the continental crust is unaffected.
Another unexplained piece of evidence was the presence of plants and animals across large bodies of water. These species would not be able to swim or travel far to establish themselves thousands of miles away, so it was suggested that they were together at one point in time.
In addition to that, they have found evidence of wildly different climates in places that have very different weather today. For example, snowy weather in Africa. Those are just some of the many recent discoveries that support Wegener's theory. Now that we have your attention, let's discuss how they move. In the 1960s, Henry Hess examined maps of the mid-ocean ridge and suggested that ocean crust moves like conveyor belts. Basically, hot liquid rock rises to the upper mantle and the cooler rock is lower. This process repeats to move the oceanic crust in a never-ending cycle. This process is similar to a treadmill or the belt in the engine of a car.
Now that we know about the mantle, let's jump to the three convergent boundaries. First of all, what are they? Convergent boundaries are locations where plates move toward one another. The first one is oceanic continental convergent. That's when ocean crust converges with continental crust. The less dense continental plate forces oceanic plate downward into the mantle. This process is also known as subduction. The subducting plate causes melting in the mantle above the plate, causing the magma to rise up and then creating volcanoes. The second plate boundary is oceanic convergent. That's when two plates collide and the older plate subducts beneath the other because it's more dense. An ocean trench then marks the location where the plate is being pushed down into the mantle. In this case, the line of volcanoes that grows on the upper oceanic plate is known as an island arc. And lastly, continental and continental convergent. That's when two continental plates collide and compress and push upwards, creating mountains. And because this type of convergence doesn't take place in the mantle, there is no melting, therefore no volcanoes.
Another type of boundary is a divergent boundary. Long story short, the plates move away from each other. During oceanic divergence, the plates move away and a ridge forms between them. The ridge spills magma from the mantle onto the seafloor and creates new crust. The new crust spreads out and causes the plates to move further apart. A similar thing happens between continental plates when they divide. When plates move apart, a rift is formed between them. Sometimes water or oceans leak into the rifts to create lakes. It's mostly just a lot of normal faults which look like this. The last type of boundary is a transform boundary, and it is where two plates kind of slide past each other. This causes a lot of earthquakes, and the other boundaries can cause earthquakes, but this one causes a lot of earthquakes. That is all we have for you today. Thanks for sticking around to learn about plate tectonics.